So let's take a little time here to talk about peer-to-peer. What we're looking at here is a standard setup in a relational world, the client-server model. It's been around for years and years. I'm sure you've seen it. Let's talk about how it works with replication strategy in a relational setup. You have a leader node, and that node is pretty much responsible for everything, such as inserts, updates, and reads. But then you had read replicas behind the leader node. These replica nodes are set up with a little bit of a lag. They're not set up the same way as the leader node because they're just copies. And what happens with this setup? Well, we shard it. Sharding? Really? What kind of problems happen with sharding? Well, let's take a closer look. We have our data spread out over multiple shards. Each shard could store a certain segment of your customer's data, things like that. What happens then? Well, then some routing has to happen, which means that you probably have to write some code to figure out where to put the data or where to find the data when you need it. That means you don't have the benefit of joins, aggregations, or group bys because of the way your data is spread out. So what if something happens to that leader? If he suddenly goes down, we are now in a world of hurt. We are in a situation where we have to wait for the dreaded failover. Time is money, people. We can't afford failovers because it could take seconds, sometimes many seconds, for a new leader to be elected. This is time that your users are sitting there staring at their app, waiting. They're just waiting. Another situation that can occur is when you have nodes that can no longer see each other. This is bad because leaders can't see the followers, and we're all in a bad state. This can lead to chaos. If those nodes can't see each other anymore, this completely messes up stuff in a highly consistent system. The followers have to be consistent with the leader, and if they can't see the leader, or the leader can't see them, they can't be consistent. When this happens, new leaders have to be elected. Oh no, but now you have two leaders! The sky is falling! How does this work in a real peer-to-peer system, which is probably what you wanted to start with? In Apache Cassandra, it works like this. We have replicas of data in our cluster, and those replicas are all equals in this peer-to-peer setup. No one is a leader, no one is a follower. They're all the same. So there's a coordinator, which you may have heard about in another module. That coordinator takes the data from the client and writes asynchronously to each replica node responsible for that data. Let's say the data is sent to a coordinator on the other side of that cluster. No problem. That coordinator will send the data to the correct replica set as well. Yay! Everything is golden here. What if we split this cluster right down the middle? Oh no, split brain problem. Or is it? No, because Apache Cassandra handles this problem automatically. This is not a failover event. Each node that can still be seen by the client is actually still online. As long as you can write to a replica, you're still up and running. This is configurable as well. You can dial this up so you're intolerant of this situation, or dial it back down so that you're totally tolerant of this situation. But you have the power to control this to fit the needs of your environment. When you write to the coordinator on one side of the partition, it'll write that data to the replica or replicas that it can see. From the other side, in our example, it can see two replicas, so it will write to both of them. This is managed by consistency level, which is talked about in a different module, but it's critical to get your head around, so make sure you make your way over there at some point. The way that Apache Cassandra is designed is to keep you online when bad things happen. Like, for example, someone spills coffee in the server room and brings down a bunch of nodes, or someone cuts through a cable somewhere, or some other minor or even major catastrophe happens. Apache Cassandra is built to manage these eventualities and keep you plugging along.